Hello everyone, this is Lab 1 for Physics 2212 at Georgia Tech, Section P. In this lab we are dealing with the interaction of forces between pieces of tape where they are organized and folded in different ways. In doing this we will need to understand what forces are acting upon the pieces of tape, and in the scenarios we are given, the only forces that we will deal with are the gravitational force and electric force, as well as the overarching idea of electric fields and how the sign influences the direction. The formula at the top is the formula for electric force, although electric fields will matter in this overall lab in regards to the direction of this force and the other pieces of tape. We're more focused on the electric force because in this lab it is the only thing offsetting the gravitational force. Going further into detail, the only difference between electric fields and electric force is simply the direction of the force, as well as the fact that in calculating the exact value for electric fields, it does not involve both charges, simply the value of the charge that is enacting the force. Lastly, we simply care about the gravitational force, but in this case, because it is short distance and is not involved with two things of very large magnitude, we will simply use the force of gravity equation to equal m times g, or the mass times the coefficient of acceleration due to gravity, which is 9.8 meters per second squared. Prior to going into the most important section of this lab, when we are gauging the floating tape, I needed to make some assumptions or guesses in regards to the nature of basic tape attractions. For example, because we know the basic laws of electrical attraction, and that two charges, like charges, repel each other. If we were to place two U-tapes next to each other and hold them by the ends, they would repel each other at the bottom, because as we know from the later pin trick, they are both positive charges pushing each other away. If we were to put the U-tape near neutral objects such as a book, we would accept a small attraction or natural movement, but not to the extent of opposite charges where there is a true attraction, like the negatively charged pen, when we will see later on. When we did this after our assumptions, what we claimed was proven correct, because we know the pen, after running it through a carpet, wool, hair, or any similar substance, will turn its exterior charge negative. When we put it close to a piece of tape and it connected or attracted, we proved that the tape was positively charged. Because in this situation we know that the top piece of tape is motionless, we understand that the net force acting on the object must be zero. Going further into detail, because the ends of the tape are attached to motionless points, we know that no matter what, unless nature of the experiment is ruined, there is no going to be a new foundation, thus zero change in x position. Continuing on, we know that primarily leaves the y component, because for the sake of simplicity we are not trying to think about the z component too much. In the y component, the two forces that are acting upon it are the force of gravity in the negative y direction opposed by the electric force by the other piece of tape, which is acting in the positive y direction. We know this because for the system of the tape to be motionless or have no change in momentum, the entire net force on the system must be zero. Based on this, if we know for a fact that there is gravity acting on the tape and it is acting in the negative y direction and it is still motionless, the electric force must be actually equal in magnitude, but opposite in direction. Getting back to the calculations, we're going to be using the formula I showed earlier in the video to calculate the electric and gravitational force on the piece of tape. As previously mentioned, we know that the magnitude of the gravitational force is equal to the electric force, and thus, by calculating the gravitational force first, I can use that value and set it equal to the electric force equation. In doing so, we know the magnitudes are equal, and on top of that, I am able to find the charge for a single piece of tape. Continuing on, here we have my GLOWSCRIPT code, which aims to show the electric force or total forces acting on the top piece of tape, which in this case is the blue sphere. Here we have two arrows. They are equal in magnitude and opposite in direction. The orange sphere is enacting the orange arrow, and that's why they're the same color, while the green arrow is acting as the gravitational force. The assumptions that needed to be made for this were the fact that the piece of tape was motionless, meaning that due to the lack of change in momentum, the net force in the system must be zero. Due to this, we assumed that air resistance and any other confounding variables were irrelevant and did not change anything enough. Thus, because of this, we could say that the electric force was the only other force acting in the opposite direction from gravity. Thus, because its force was positive in the y direction, it was equal to the magnitude. Also, we considered the tapes to be point charges, which is inaccurate because the forces normally would be acting differently on different points of the strip of tape. Here is briefly the corresponding calculations for the number of electrons versus the number of atoms and their ratio. Finally, we get to the what if and why questions. If protons had a negative charge and electrons had positive charge, how would this change our observations with tapes and other charged objects? Originally, I believed that it would flip it to the opposite. However, this is incorrect. It would not change our observations whatsoever. For example, when we look at the pen test, when you rub a pen through wool, cotton, or hair, it creates a negative charge in the exterior or plastic coat of the pen. However, because our tape attracted to this, we know that our tape was positive, so we have a negative charged pen and a positive charged tape. However, if the value of protons and electrons would flip, our negatively charged pen would turn positive and our positively charged tape would turn negative and they would still attract. Lastly, why is it important to handle the charged tapes as little as possible? It is very important to not touch or handle the tape as little as possible, simply because each of our interactions with the tape, specifically physical interactions such as touches, cause transfers of electrons between the tape and our hands. Due to this, as we repeatedly touch the tape, electrons will more and more be transferred from the tape into the hand or body, which will end up producing a quote-unquote dead piece of tape where it has very little charge and is more neutral than anything. That's all for today. Thank you for listening.